This is section 12.2, combinations and permutations. So with a combination, order does not matter. You see things like committees, just selecting, and that's a C, choosing. With a permutation, the order is important. So you see words like arranging, or there's some type of ranking, first, second, third, fourth, ranking or ordering. And we'll see some examples that'll make more sense. There's a little spot for your calculator notes. So we're going to do some ones where you just evaluate. So C is for combinations, P is for permutations. Okay. So let's flip over to the calculator. So we have a combination. So use your area on your note guide to write this. So you're in just regular calculate screen, and you're going to hit menu. And we're dealing with probability. And our first one is a combination. So we have 4 items. Stick your comma in. Comma's on the bottom left of your screen. 2. Okay, so you have 4 objects and you're choosing 2 at a time. So there's 6 ways you can do that. So then we have a combination with 10, 8. So for instance, saying if you're going on a trip, you have 10 books, 10 favorite books, but you can only take 8 on the trip. The order doesn't matter. Okay. So there's 45 ways you can choose 8 of the 10 books that you have for the trip. The next 2 are permutations. Okay, so it's 5, 4. Perhaps you have 5 books and you have enough space to put 4 of them on a shelf, but you're going to arrange them. So there's different ways you can, different orders that, a different order that you can put the books in. Okay, so there's 120 ways you can do that. And then permutations, 12, arranged 5 at a time. So we have 12 items, and we're arranging 5 at a time. So there's 95,040 ways to do that. And these are pretty straightforward. It tells you it's a permutation or a combination. So we're going to have 12 objects taken 5 at a time with a permutation, which actually we just did. So that's 5,040. Then permutations, 13 objects taken 8 at a time. Or arranged, rather, since it's a permutation. 8, 9, 18. Okay. Number of combinations, we have 14 objects taken 4 at a time. $24,024. And 15 objects taken 7 at a time. 6435. So 6,435 ways. Those are pretty straightforward. So we're going to look at some applications here. Molly makes floral arrangements. She has 22 different cut flowers and plans to use 6 of them. How many different selections of the 6 flowers are possible? They're not saying that she arranged them in a specific order. So there's no type of ordering. So that's a combination. And of the 22, she can use the 6 for the arrangement. Okay. 74,613 ways. All right, Kevin must select an answer in any order 4 of the 8 essay questions on a test. And how many ways can he do so? It says in any order, so order does not matter, so that is a combination. Of the 8 essay questions, he has to answer 4. So perhaps, you go to take a test and the professor says there are 8 essay questions. You only have to do 4. You pick which 4 to choose from and write on that topic. Okay. So how many ways can we do that? So there's 70 different ways you can choose 4 of the 8 questions. A skiing event has 16 participants for the slalom. And forgive me if I pronounce that incorrectly. The 4 participants with the fastest speeds will be listed in order of their speed on the leaderboard. How many different ways are there for the names to be listed? So there is an ordering. Okay, first it tells you order, and it says fastest speeds, and it's a race. That's something else to tell you. So this is going to be a permutation. So of the 16 participants, how many ways can 4 of them be arranged? So how many ways can we list the 4 top speeds if we were to have 16 participants? Permutation, because there's an ordering, there's a ranking. So it does matter if you come in first, second, third, or fourth place. If you think about it like that. 43,680. So maybe just the top person goes on to state or a national event. So whether you get first or second is going to matter. 3 different colored flags will be placed on a pole, one beneath another. The arrangements of the colors indicate a message. How many messages are possible if 3 flags are to be selected from 20 different colored flags? So here's a key word, is the arrangement of the colors. That's telling me there's some type of ordering. Okay. So that order matters. It's permutation. There are 20 different colors to choose from, and they are arranging 3 at a time for a specific message. So 6,840 different messages that can be displayed. Describe the number of ways to perform the task described. Determine. I think I just read that entire thing wrong. 9 players are to be selected from a 20-player baseball team to visit schools to support a summer reading program. And how many ways can this selection be made? So does the order matter? The order doesn't matter. It doesn't say there's any type of ranking. They don't say like one's in charge, one does refreshments or anything like that. They're just sending 9 players to a school to help this summer reading program. So that's a combination. You have 20 players to choose from, and you're going to choose 9 to participate in this program. How many ways can this be done? So that's how many ways we can select 9 from a 20-player baseball team. All right. From 7 male and 9 female sales representatives for an insurance company, a team of 3 men and 4 women will be selected to attend a national conference on insurance fraud. So first of all, is there any type of ranking? I just see the word team. Okay. But this one's going to be done a little bit different. So think about this. We need 3 men and 4 women. All right, so we're going to have to do 2 different ones. Team, I don't see any type of ranking in there. So for the men, the combination is going to be what? We have 7 males, and we're going to choose 3 to go to this conference. Same thing for the women. It's a combination. The order doesn't matter, but we have 9 females, and we are selecting 4 to go. Right. It's 35 ways to select the males. Get the females while I'm here. 126 ways to select those females. And what do you think we do with these 2 numbers? We are going to multiply them. Fundamental counting principle. So it's 4,410 ways to create this team. The town is forming a committee to investigate ways to improve public safety in the town. The committee will consist of 2 representatives from the 5-member town council, 2 members of a 6-person citizens advisory boards, and 2 of the 10 police officers on the force. How many ways can that committee be formed? Okay, so it's a committee. There's no ordering. Not one person has more authority than the other. So we have the town council. So it's a combination. There's 5 on the town council, and we need 2 of them for the committee. And then we have the advisory board. So there are 6 people on that board, and we want to select 2 of them for this committee. Then finally, for the police officers, of the 10, we want to select 2. So we have 2 people from each of these different groups, so there's an equal representation. And again, as we did before, whatever these numbers are, we are just going to multiply them together. If you want to, you can actually go ahead and multiply them. Just put them in there. You can do the numbers individually like I did with the last one. 6. So 6,750 ways. Gina must write evaluation reports on 5 hospitals and 6 health clinics as part of her degree program in community health services. If there are 13 hospitals and 10 clinics in her vicinity, and how many ways can she complete the assignment? Okay, so does the order matter? There's no indication of any type of ordering. So for the hospitals and the health clinics. So for the hospital, she needs 5 of the 13. So she needs 13, 5. And for the health clinics, there are 10 clinics, and she needs to do reports on 6. So again, you just multiply these together. You can do these individually, then multiply the numbers, or you can stick it in all as one. All right. 270,270 ways to do that. Then our last one, the students in a 20-member advanced communications design class at Center Community College are submitting a project to a national competition. They must select a 4-member team to attend the competition. The team must have a team leader and a main presenter, and the 2 other members have no particularly defined roles. And how many different ways can this team be formed? So let's think about that for a minute. All right, so this was a little bit different. We have 4 people we need. Okay. Now of those 4, we have a team leader and a presenter. So 2 have defined roles. So there is some type of ordering. And then 2 other members may just go, I don't know, just to fill a seat. So they don't have any particular ordering. So we do have 2 different ones. We have the team leader and the presenter. And that ordering is important. So that's a permutation. So we have 20 members, and we need to select 2 for the team leader and the presenter. But then we just have 2 random members that we need to choose. Their order doesn't matter. They have no ranking, no defined roles. All right. So after we've chosen our team leader and our presenter, how do we set up for just the 2 members that we have left? That's going to be 18, 2. Because once we select the team leader and the presenter, that means we only have 18 people to choose from. And again, we're going to multiply those. It's 58,140 ways. And you could have set this up in the reverse. Permutations 18, and you would have got the same answer. And that's it for chapter 12.